Alright, so it's time for weekly contest 189. I am super excited to do better than I did on today's bi-weekly contest, which I scored rank 3000 on. So, yeah, let's go. Let's do better. Yes. Let's go. Right, so when I said I wanted to do better, I actually did a lot better than I actually thought I would do. So I got rank 151. Yay! So that's because I finished all 4 problems, and I did it relatively quickly except for problem 4. But that was pretty fast too. It was in under an hour, so that was good. I got 1 bug on problem 4 for something that I will probably explain. I will write down to explain that. Okay, so let's dive right into the explanations. Problem 1. Number of students doing homework at a given time. You are given 2 integer arrays, start time and end time, and given an integer query time. The ith student started doing their homework at the time, start time, and finished it at time, end time. Return the number of students doing their homework at time, query time. More formally, return the number of students where query time lays in the interval start time I, end time I inclusive. This is quite simple. Basically, we just loop through every single student and see when they started, see when they ended, see if query time falls between that range, and if it does, that means that student was doing work during that time, and that means we add 1 to the total, and then at the very end, we just return the total. So that's a very simple number 1. Problem 2. Rearrange words in a sentence. You are given a sentence text, in the following format. The first letter is in uppercase, and each word in text is separated by a single space. Your task is to rearrange the words in text such that all words are rearranged in an increasing order of their length. If two words have the same sign, arrange them in their original order. Okay, so this is not too hard if you're using a language that can do sorting, using custom comparators pretty well. So Python is one of those languages, and one of the things we can do is split the text apart into several words, and then we can actually sort the words based on their length, which is what we're asked to do, using this key argument here, which basically is a comparator. Basically, it takes in two elements and then compares them, and this is used in the general sorting function. So basically what we do here is we set the comparator to true if it's longer and not true if it's shorter. So yeah, and then we loop through every word, and actually no, we sort all the words based on their length, and then at the very end we just make sure all of them are lowercase, and then we set the first word to uppercase, and that is it. Problem 3. People whose list of favorite companies is not a subset of another list. Basically everything is in the name in this one. We just are given a list of favorite companies, where favorite companies I is the list of favorite companies for the ith person index from 0. Return the indices of people whose list of favorite companies is not a subset of any other list of favorite companies. You must return the indices in increasing order. Brute force worked on this one for me. We just loop through every single person. For every single person, look at every other person and see if the first person's list of favorite companies is a subset of anyone else's. And then we can return that it is a subset of another list, and otherwise we can return false. So we can do this in n squared time. Determining the subsets would take, but that's not a very big factor. That's just 20. So in fact we can do this in under the time limit. And we're given that the company's length is 100 for every list of favorite companies. So that would, n squared would be 100 squared, which is 10 to the 4, and then multiplying on the extra 20 for comparing if it is a subset would make it 10 to the 5 times 2, which is short enough, and it actually works. And at the very end we have to remember to return the indices in increasing order, so maybe that might have caused a few bugs for a few people. I'm not sure. Probably not too many though. Problem 4. Maximum number of darts inside of a circular dartboard. You have a very large square wall and a circular dartboard placed on the wall. You have been challenged to throw darts into the board blindfolded. Darts thrown at the wall are represented as an array of points on a 2D plane. Return the maximum number of points that are within or lie on any circular dartboard of radius r. Yeah, basically just the problem statement. We're given number of points, and we have to find the maximum number of points that can fit inside a circle of radius r. The algorithm I used was brute force. Yeah, I've done quite a bit of brute force today. So you consider every pair of 2 points. There are n choose 2 of these, which is basically just n times n minus 1 all over 2. And that is just n squared. So we consider every pair of possible points, and there are 2 circles of radius r they can pass through. We can see if I draw something here maybe. So if you take a point, if you take 2 points, like the circles that have radius r must pass through their perpendicular bisector. And this is like some geometry. You might need to know some geometry to do this problem. Any circle that passes through 2 points must pass through the perpendicular bisector between those 2 points. And if we consider like the circle must have radius r, we just specify perhaps a center, and then like we say, oh, the radius has to be like 5 or something. There are only 2 points that lie on this perpendicular bisector that satisfy that. They are these 2 points. And therefore the circles of radius r, they must lie either at this center or this center. Yeah, so there's only 2 possible choices for each pair of 2 points, and we can determine those 2 using some math, and I will explain that math here. And if you're not interested in the math and you just want to see what happens later, skip this. So we're given these 2 points, A, B. and we want to determine the two circles that have radius r that can fit here. So since we're given r, we know that this segment must exist of length r. We also know the midpoint of AB, which the perpendicular bisector of AB must pass through. And that's basically all we know. And then we want to find the point C, which is the center. And there are actually two, so you have to have a C1 and a C2. So we know this is a right triangle, the triangle formed by A, the midpoint between A and B, and the center. So we know the distance between the A and the midpoint because that's just the distance between A and B divided by 2, right? And since this is a right triangle, we can use the Pythagorean theorem. So we can get that the distance between the center and the midpoint of A and B is the square root of r squared minus the distance between A and the midpoint squared. And using that, we can determine the distance between the center and the midpoint. After that, we can look at this triangle. But first, we have to know the slope, right? Determining the slope of the perpendicular bisector is not hard. It is -1 over the slope of AB. And that is like a fact about perpendicular lines that you just have to learn in geometry, right? I mean, I could prove it, but I don't want to. So if we know the x distance between the midpoint and the center is x, then we know that the y distance between the midpoint and the center is x times slope, because that's how slope is defined. It's like rise over run, right? So we know that the sum of the squares of these two legs equals the distance between the midpoint and the center. And we already found that in the previous calculation. So we know that x squared plus x times slope quantity squared equals this length squared. And that means if we do some algebraic manipulation, we know that x equals the square root of this distance squared over 1 plus slope squared. And using that, we now know the coordinates. We know the length of the legs of this triangle, but using that, since we know the midpoint, we can extrapolate the location of the center. And then similarly, we can also find the location of the second center. Also, there's a caveat. If these 2 points are vertical, then the slope of the perpendicular bisector is actually undefined, because it's a vertical line, and vertical lines don't have defined slopes. So what we can actually do here is we can say, okay, the midpoint still has to lie in the perpendicular bisector, even if we can't define it. So its x coordinate must be equal to the same as the midpoint between these 2 points. We also know that this length has to be r. And since we know the distance between a point and the midpoint, we can use the Pythagorean theorem to find the vertical distance from the midpoint as well. So using that, we can find the 2 centers if it's vertical. Okay, yeah, I think that's all the edge cases. So yeah, this is the math. And at the very end, we have figured out the 2 possible coordinates of the center for any 2 given points. Oops, okay. Using that, we can now find the equation for the circle. Or we don't actually have to know the equation for the circle. We can just know that the circle exists. So we can write a function to find the total number of points that can be contained in a circle given its center and radius. Because we know, using the distance formula, that the distance between a point and the center of the circle, if that is less than or equal to the radius, then the point lies inside the circle. And we can just do that here. So yeah. Yeah, and at the very end, not the very end, and then we can see if a point lies inside the circle, and we do that for all the points to see the total. And at the very end, we can just max that with the original maximum, which starts out at 1 because a point of radius r can just be put directly on any point, and that can just cover that point. So the minimum is actually 1. Yeah, and then we're done. I did not think this would actually work, but it's not that bad because n is only 100, and this runs in n squared time times the number of points, which is n. So it actually runs in n cubed time, and that's about 1,000,000. And 1,000,000 is okay. It's not dangerous at all. And we might have some stray coefficients for calculating math, but math is usually fast on a computer. At the beginning, I forgot some squares, and I kind of blamed that on the accuracy of decimals in Python, but that wasn't really the problem. Python's pretty accurate with its decimals. I don't think they try to trip you up with any like really close points or circles. So, yeah, hopefully I explained that well. Okay, so yeah, this contest was a good contest. Actually, it was a really good contest. I got top 200. Yay. Yeah, okay, yeah, I have to explain why the bug is here. It's because I forgot to do this part. So I didn't actually use the Pythagorean theorem. I just kind of like, I don't actually know what I did, but I did something wrong. So yeah, that's why I got the bug. Okay, good contest. Yeah, hopefully my explanations were good, especially for problem 4. That might have been a bit of a less detailed or clear solution. So yeah, I hope you enjoyed watching this. Thank you. Goodbye.